Hello, and welcome to this presentation, Getting Started with the LMG600 GPIO and Sync interface. This presentation explains how to use the GPIO and synchronization interface of LMG600 series precision power analyzers. The GPIO and Sync interface is a DB15 style connector on the rear panel of the LMG, located near the bottom of the base module. The pins of this connector can be used for input and output, with most pins having a configurable signal direction. There are three main functions of the GPIO and Sync interface. The first is general purpose input and output of electrical signals. This is generally used when interfacing the LMG with the device under test, or with other test and measurement instruments. The second is monitoring or controlling measurements, for example, triggering a transient measurement or starting/stopping an energy integration measurement. The third is synchronization between multiple LMGs. In this case, the connector is used for both input and output of signals that allow multiple LMGs to function together as a single unit. In the remainder of this presentation, we'll look more closely at each of these applications. The GPIO and Sync interface is configured by pressing the instrument hard key and then going to the tab GPIO and Sync. In the top left of the GUI, the direction and state of the GPIO pins is shown, and the bottom of the GUI shows information regarding the synchronization pins. The buttons along the right side of the GUI allow for user control over the state and direction of many of these pins. And finally, this GUI also contains a diagram which shows the pin numbers and their assignments. Let's take a few moments to look more closely at the pin assignments on this interface. Recall that this is a DB15 style connector, so there are 15 pins. Pins 1 through 9 are primarily used for synchronization and measurement monitoring/control, but note that pin 3 is reserved and that pins 4 and 5 are connected to ground. On the other side of the connector, pins 9 through 15 are used for GPIO, the only exception being pin 12, which is at +5 volts. As mentioned on the previous slide, these pin assignments are graphically displayed within the main GPIO and Sync interface as well. Let's come back and take a closer look at the upper part of the screen, which shows the direction and state of the 6 GPIO pins. These pins can be used either as inputs or outputs, and this is selected using direction. If a pin is configured as an output, the state, high or low, can be set using Set State. It's also worth noting that pin state and direction can be controlled programmatically, that is, using a script. And if a pin is being controlled programmatically, this will be indicated as script control in the Set State column. Before discussing the synchronization pins, let's briefly explain instrument synchronization. A single LMG671 can support up to 7 power measurement channels, and this is sufficient for most power measurement tasks. However, higher channel counts can be obtained by combining 2 or 3 LMGs together. This requires the instruments to be connected using a so-called sync cable connected to the GPIO and Sync interface. The master/slave relationship between these instruments is determined by the direction of the signals on this interface. When properly connected, LMGs will be able to synchronize cycle timing, system time, transient triggers, and the energy integration state. The pins involved in synchronization and control are displayed in the lower area of the GPIO GUI. In particular, the time I/O, cycle I/O, and frequency signals are primarily used for synchronizing multiple instruments. In addition, the transient I/O pin is either asserted when a transient trigger event occurs, or can be used as an input trigger to start a transient measurement. The energy I/O pin is asserted whenever an energy measurement is running, or it may be used to start and stop an energy measurement. Please see the separate presentations on transient and energy measurements if you'd like to learn more about these topics. Let's end with a brief summary. The GPIO and Sync interface is located on the base module of LMG600 series analyzers and is configured and monitored via the GPIO tab under the Instrument menu. The GUI shows both the pin assignment and status, as well as a labeled pinout diagram of the connector itself. This DB15 type connector can be used in three main ways. The first is for general purpose input and output, primarily for interaction with the device under test and/or with other test instruments. Several signals can also be used to control and monitor measurements, in particular transient and energy measurements. Most of the remaining pins can be configured to provide the signals necessary to interconnect and synchronize multiple LMGs into one logical test system. This concludes our presentation, getting started with the LMG600 GPIO and Sync interface. If you'd like to learn more about the LMG, power measurements, or related products from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.